Hey guys, my name is IBM and I am solving May June 9702. This is 2024 and this is paper 1-1. This is multiple choice questions. So paper 1 multiple choice questions. I'll not go through the instructions. We are used to the instructions. I'll go straight to the questions. We are used to the data. We are used to the formula. So question number 1. Which unit is an SI base unit? Remember, we have 7 SI base quantities and their units are the SI base units. So, for example, we have mass, whose units are kilograms. We have current, whose units are amperes. We have time, whose units are seconds. We have length, which is measured in meters. We have luminous intensity, which is, I think, measured in candela. We have amount of substance, which is measured in the mole, and we have absolute temperature, which is measured in Kelvin. So these are the base units. So the question is, which unit is an SI base unit? So it means all these ones are not among those 7. So the answer is automatically A. Which of the following could have the same units as force? So we need to find a quantity which has the same units as force. So we just simplify each of these and see. So energy can be the same as work done. So this is work done divided by distance. But work done can be force times displacement in the direction of the force. So this is divided by force. So displacement has cancelled with that because distance and displacement will have the same units. So this will be the same as the units for force. So which of the following could have the same units as force? So that is going to be A. Alternatively, you can write the units for each of these. For energy, energy is kilogram, meters per second squared. Then distance is in meters. So this is the kilogram meters squared per second squared. So this cancels with that, which becomes kilogram meters per second squared. And of course, kilogram is mass. Meters per second squared is acceleration, and mass times acceleration is the same as force. So our answer is A. The velocity of an object changes from an initial velocity u to the final velocity v. The vectors represent the velocities. So these are the vectors. Which single vector represents the change in the velocity? So which single vector represents the change in the velocity? So let's say the change in velocity is delta. Let me just call it uv. Let me call it w. That is the change in velocity. So remember, this is the final velocity. So it means when I get u plus the change in velocity, I should be able to get v. That's what it means. When I get u plus the change in velocity, I should be able to get v. So we can try to check. V should be vertically downwards. So there is no way I will add. If we say this is W, these ones are representing W. If on W I add U, for example, on W I add U, the resultant will be in this direction. The final velocity will be in that direction. So it means A is out. So A is out. Then on B, if on W I add U, remember U is in the horizontal. If on W I add U, then it means the resultant is going to be in this direction, yet the final should be vertical down. So it means B is also out. Then C, if on W I add U, remember you don't need to change the direction for U, it is to the right. So if on W I add U in this direction, this is forming an anti-clockwise loop. Then V is going to be the resultant, the final is going to be vertically downwards. which is the other way around. So it means the answer is automatically going to be C, where this would be U. The other one is W, which is the change. And this is the final velocity, which is going to be V. So the answer is automatically going to be C. You can check with the D. If on D, if Wi add U to the horizontal, it means the resultant would be like this, which would be pointing upwards. Remember, this is forming a clockwise loop, then the resultant should be the other way around, anti-clockwise. So yet the final should be downwards. So it means D is automatically wrong. So the answer is going to be C. An object is moving with the initial velocity u. The object then moves with a uniform acceleration. That means equations of motion can be considered for a time t until it reaches final velocity v. Which equation describes the motion of the object? So all these ones are equations are relating to equations of motion, which we know one v equals to u plus at. So when we try to look at these equations, when I make u the subject, u is going to be v minus at. So the answer is automatically B. Which equation describes the motion of the object? So we don't have this equation. The other equation is v squared equals to u squared plus 2as, which we don't have here. The other equation is s equals to ut plus a half at squared. So it means this is wrong, this is wrong, and this equation also does not exist. So the answer is automatically B. Which calculation produces a vector quantity? Remember, a vector quantity has both magnitude and direction, and there are 6 vector quantities at your level. We have velocity, talk about force, talk about acceleration, we talk about momentum, and of course the change in momentum, which is impulse. We talk about moment, and we talk about displacement. These are the only vectors you should be thinking about in your AS level, because the others are in A level. So we have to look for which of the products gives us n of these. So current is current times time. Current times time, this gives us, I think this is charge. Current times time, I think this is charge, because current is equal to charge over t. So current times time is charge, so this is not a vector quantity. Final displacement minus initial displacement. Final displacement minus initial displacement. Which calculation produces a vector quantity? So final displacement is a vector quantity. Initial displacement is a vector quantity. So the resultant is also a vector quantity. So the answer should be B. Let's check C. Work done is force times distance divided by time. So this gives us power. And power is a scalar quantity. A half mv squared, this is kinetic energy, which is also a scalar quantity. So our answer is going to be B. A thermometer can read to an accuracy of plus or minus 0.5 degrees Celsius. The thermometer is used to measure a temperature rise from 40 degrees Celsius to 100 degrees Celsius. So it means the rise in temperature is going to be 100 minus 40, which is equal to 60 degrees Celsius. That is the rise in temperature. What is the percentage uncertainty in the measurement of the temperature? Let's first find the absolute uncertainty in temperature. Remember, whenever we subtract values, the absolute uncertainty just adds up. So the absolute uncertainty is equal to just twice of 0.5, because this one has an uncertainty of 0.5. This one also has an uncertainty of 0.5, so they just accumulate. So the absolute uncertainty is going to be 0. Okay, it is 1.0 degrees Celsius. That is the absolute. So we want to find the percentage uncertainty. So the percentage uncertainty is going to be the absolute over the rise in temperature. Then I'll multiply this by 100. So this is going to be 1 divided by 60 times 100, which gives us 1 divided by 60 times 100, that is 1.66 recurring, which is 1.7%. So this is 1.7%. So the answer is going to be D. The diagram shows the path of a golf ball. Which row describes changes in the horizontal and vertical components of the velocity when air resistance is ignored? So when air resistance is ignored, the only force acting is the force due to gravity. The force due to gravity is the only force which is acting when air resistance is neglected. So, and this one acts vertically downwards. So it means there is no force in the horizontal, no force in the horizontal. And if there is no force in the horizontal, it means acceleration in the x is equal to 0. The acceleration in the horizontal is equal to 0. So velocity in the horizontal remains constant throughout. So the question is, which row describes changes in the horizontal and vertical components of the golf ball's velocity when air resistance is ignored? So in the horizontal, when I say ax, it means the acceleration in the horizontal. Vx is the velocity in the horizontal. So in the horizontal, the velocity remains constant because there is no acceleration. So we start with that. Horizontal velocity remains constant. So we ignore A and we ignore B. So the velocity in the horizontal remains constant, but then in the vertical, remember, in the vertical, the force acts vertically downwards. So when the ball is moving against gravity, the velocity decreases. This part here, v in the vertical, decreases. At the highest point, v in the vertical is equal to 0. And this part here, v in the vertical, increases. So of course, the acceleration is constant and equals to the acceleration in the vertical is constant and is equal to 9.81 meters per second squared. So we have to choose between C and D. Velocity in the horizontal is constant, then the acceleration must be constant. It is always acting downwards, so the answer is automatically going to be C. The acceleration is 9.81 and it acts towards the center of the Earth because it depends on the mass of the Earth, so it is constant. An aircraft flies from London to Sydney in a time of 21 hours 40 minutes. The distance traveled is 17,000 kilometers. What is the average speed? So the average speed is equal to the distance divided by the time. So the total distance is 17,000, but is in kilometers. So I'll first change it to meters. So that is times 10 to the power of 3 or times 1,000. Divided by the time is 21 hours. I will change it to seconds. So it is 21 times 3,600, then plus 40 minutes. So it will be 40 times 60. So I'm changing the total time to seconds. So from my calculator, I have 21 times 3,600 plus 40 times 60. Then I have 17,000 times 1,000 divided by the answer. So this is giving me 217. 217 meters per second, or 218, or approximately 2.2. So this is 2.2 times 10 to the power of 1, 2 times 10 to the power of 2 in meters. So this one is, sorry, meters per second. So this one is, this A is wrong. Then let's check a micro. If I change to micro, this is going to be 2.2 times 10 to the power of 2. To bring in a prefix, we divide by its value. So I divide by 10 to the power of minus 6, which is going to be 2.2 times 10 to the power of 8 meters, micrometers per second. So this is also wrong. Then when I check nano, for nano, this will be 2.2 times 10 to the power of 2. Nano is 10 to the power of negative 9. So I divide by power 9 minus 9, which gives me 2.2 times 10 to the power of 11 and nanometers per second. So the answer is C. A golf club hits a golf ball. The graph shows the force F on the ball varies, how the force F on the ball varies with time t. Which graph shows the velocity? Which graph shows how the velocity v of the ball varies with the time t? So first of all, we know that force is directly proportional to the acceleration, and we notice that for the first half of the time, the force increases uniformly, so the acceleration increases uniformly. And here, so here force increases, acceleration increases. Here force decreases, the acceleration also decreases. So the graph should have two parts where the acceleration decreases, increases, and then it decreases. And remember, acceleration equals to the gradient of a velocity time graph. The acceleration is the gradient of a velocity time graph. So here we have been given velocity time graphs. So we should check a point where the gradient increases and then it decreases. So A is showing that the gradient decreases. Here we are seeing a decrease in the gradient because the line is becoming horizontal and then the gradient is increasing. So A is wrong because here the acceleration is decreasing and here the acceleration is increasing because the gradient is increasing. So A is wrong. Then we can see B. I think B is correct because here we see that the gradient is increasing because the line is becoming steeper. So here acceleration is increasing because the gradient is increasing. Then here we see that the line has become horizontal. So here acceleration is decreasing because the gradient is decreasing. And of course, when the force becomes zero, when F equals to zero, the acceleration is equal to zero. So the gradient should go to zero. So that's why we have a horizontal line here, which shows acceleration is equal to zero here. So the answer is going to be B. What is meant by the mass and by the weight of an object on the Earth? Of course, we know mass is a property that resists the body's change, the body's state change in state of motion, that is mass. And then we know that the weight is the pull of gravity, so the answer is automatically D. Mass is a property that resists its acceleration. Then weight is the pull of gravity, the pull of the earth on the object, that is the weight. So the answer is D. A thin horizontal plate of area 0.036 meters squared is beneath the surface of a liquid of density 930 kilograms per meters cubed. The force on one side of the plate is due to the pressure of the liquid is 290 newtons. What is the depth? What is the depth? I'll call that H. What is the depth of the plate beneath the surface of the liquid? So first of all, we know that pressure is defined as force per unit force acting normally per unit area, but pressure due to liquids is density times G times H. So I'm just going to equate these two equations. So pressure is going to be 290 divided by the area, which is 0.036, should be equal to the density, which is 930 times G, which is 9.81. then times the height h. So I'll just make h the subject from my calculator. I think I need to change the position of this calculator. Okay, I'll make sure I change the calculator position. So I'm just going to say h equals to 290 divided by 930 times 9.81 times 0.036. So I'll just put this in my calculator. 290 divided by 930 times 9.81 times 0.036. Let me repeat this again. 290 divided by 930 times 9.81 times 0.036. So this is 0.88. So h is equal to 0.88. So the answer is going to be A. Spheres X and Y form an isolated system. The mass of Y is greater than the mass of X. So M of Y is greater than M of X. Sphere X collides elastically with sphere Y. The speed of sphere X before the collision is u. Which statement must be correct? Okay, so I will try to put this in a sketch for simplicity. So we initially have sphere X and we have sphere Y. This is initial moving the speed u. Let's say it is moving towards Y, and this is initial at rest. So the speed is 0. So that means we are going to conserve kinetic energy and we are going to conserve momentum, because they said sphere X and Y form an isolated system. The mass of Y is greater than the mass of X. But remember, Y is initially stationary and X collides elastically with the sphere Y. So that means momentum is conserved and kinetic energy is conserved. So if I consider momentum, conservation of momentum, let's say after the collision, we're going to say the speed of this is going to be Vx. Let's say the speed of this is going to be Vy. So we don't, of course, there is no possibility of Y moving backwards. There is no possibility of Y moving backwards, but they said sphere X collides elastically with the sphere Y. So let's first investigate the statements given here. The first one says sphere X rebounds with a speed that is greater than u. So let's assume it rebounds. Is the speed greater than u? Because all of them have rebounds. So that means Vx is going to be in the opposite direction. Speeds to the right positive, speeds to the left negative. So this is positive, positive, Vx is negative. So by conservation of momentum initially, total momentum I'll call mass of x mx times its speed, which is u, plus of course the other one is 0, should be equal to, for x is going to be negative mx times vx, then plus my times vy. So this therefore implies, if I collect like terms, I bring the m together, this implies the mx together, so it means mx into u plus vx is going to be my times vy. That is one equation. Then when I consider conservation of kinetic energy, total kinetic energy before is going to be a half mx times u squared, because the other one was at rest, its kinetic energy is 0. should be equal to the total kinetic energy after, which will be a half m of x times v of x squared. Of course, we don't put a minus here because this is a scalar quantity. Then plus a half m of y times v of y squared. So a half has cancelled out. Then I'm going to collect the mx together. So I have that m of x into u squared minus vx squared is equal to my vy squared. Remember, this is a difference of two squares, which can be simplified to be mx into u minus vx into u plus vx. This should be equal to my vy squared. So this is going to be my second equation. So I'm going to consider equation 2 divided by equation 1. So equation 2 divided by equation 1. So when I divide, I have that m of x into u minus vx into u plus vx is equal to my vy squared. Then I divide by the first equation is mx into u plus vx divide by my vy. So mx cancels, u plus vx cancels, my cancels. So if my cancels, I remain here with vy squared over vy. So I remain with only one vy in the numerator. So I have that u minus vx is equal to vy. What does this mean? It means that u is going to always be vx plus vy. So there is no possibility of any of these velocities to be greater than u because u is vx plus vy. So rebounds x, sphere A rebounds, sphere x rebounds with a speed that is greater than u. So they can't be greater. Speed x rebounds with a speed less than u, and sphere y moves off with a speed that is also less than u. So it is most likely going to be, this is most likely going to be the correct answer, because if u is vx plus vy, it means vx and vy are always going to be less than u. Sphere x rebounds with the speed u, and sphere y remains stationary. So here, if sphere x rebounds with the speed u and sphere y remains stationary, then momentum is not going to be conserved here. So this is not going to be correct. Sphere x remains stationary and y moves off with a speed that is less than u. So kinetic energy is not going to be conserved. So that means the answer is going to be B. A ball of mass 0.1 kilogram is thrown towards a stationary vertical bat. The ball hits the bat with a horizontal velocity of 20 meters per second. So initial velocity towards the bat is 20 meters per second. Then the ball rebounds. So velocity to the right positive. Then if it rebounds with a speed velocity of 15 meters per second, so this is going to be negative. So what is the change in momentum? So change in momentum is equal to mass times the change in velocity. So the mass is 0.1. Then the velocity changes from 20 to negative 15. So it is minus negative 15. So this is going to give us a 0.1 times, I think this is 45. No, not 45, it is 35. 0.1 times 35, which gives us 3.5 Newton seconds. So the answer is going to be D. An isolated object of negligible weight is acted on by two coplanar forces of the same magnitude. In which diagram is the object in equilibrium? So for equilibrium, the resultant torque should be 0, the resultant force should be 0 in any direction. So automatically, when you look at A, if this one is acting downwards, and this is acting upwards, they cancel out each other, and of course they are acting through each other, so they are not going to cause moments. This one is going to cause this to move in this direction. This one is going to cause this to move in this direction, so they will rotate. So these two are causing anti-clockwise moment, so this is not going to be in equilibrium. So this one is causing moment in that direction, this is causing moment in that direction. There's no resultant moment, but they are both acting in both directions. So the resultant force is not zero, even though the resultant moment is zero. So this one is also out. Then D, this is acting vertically downwards through the center, and this is going to cause a rotation in this direction. So the rotation in the clockwise direction is not countered with this force. So this is going to cause a rotation in one direction. So, and it can also cause there's a resultant force in this direction. There's a resultant force in this direction. So there's a resultant of these two forces which will act in this direction. So the resultant torque is not zero. The resultant force is not zero. So this one can cause motion. So it's only this one which will make the body to be in equilibrium, because each of them are acting through the same direction. So they have no resultant. They're acting through the same horizon, through the same vertical line. So the resultant force here is going to be zero because they're in opposite directions. But if they cause moments about these 2 points, the moments are going to cancel out each other. So this means the resultant torque is zero. So the answer is A. A uniform beam PQ rests horizontal on a support at point S. A rope is attached at one end of the beam. The rope is at an angle of 60 degrees to the vertical and exerts a force F in newtons on the beam. What is the moment in Newton meters of the force F? So as a mathematician, we have taken moments about this pivot here, so we just need a perpendicular distance, which is going to be this distance. We can resolve F to the vertical. So taking F to the vertical, this will be F cos of 60. So we need just the perpendicular distance of F cos 60 to the pivot, which is going to be 2.5 minus 0.3, which is going to be 2.2. So the perpendicular distance of F cos 60 is 2.2 meters. So the moment we are looking for here is going to be the force, which is F cos of 60 times the perpendicular distance, which is 2.2. I think cos of 60 is the same as sine a half. Cos 60 times 2.2, which is 1.1. So the moment we are looking for here is going to be 1.1 times F, which makes our answer to be automatically A. The diagram shows the dimensions of an elastic cord used to project a stone. The tension in the cord is T when the cord is pulled into the shape shown. Which force does the elastic cord exert on the stone? So we just need to resolve the two tensions in this direction. So when I resolve T, if this divides into 2, so this distance here is going to be 8 centimeters. This will also be 8 centimeters to give us a total of 16. So I'm going to consider this angle as theta. So theta, this is opposite, this is hypotenuse. So we know that sine theta is equal to the opposite over the hypotenuse, which is 10. Alternatively, I can find the diagonal, the horizontal here, so that I can find cos theta. So this distance here is going to be, let me call this one as C. C is going to be equal to the square root by Pythagoras theorem, C squared plus, or let me just call it A squared plus 8 squared is equal to 10 squared. So A is going to be 100 minus 64 under the square root which is 36, which A is equal to 6 centimeters. So A is equal to 6 centimeters. So the reason as why I found A is because I want us to find the cos of theta to be equal to the adjacent, which is 6, over the hypotenuse, which is 10. Why do I need the cos? Because I'm going to resolve t in the horizontal to point in the direction in which I expect the stone to move, which is in the horizontal. So the stone moves in this direction here. So resolving t to the horizontal, it is going to be, or the force we are looking for is going to be 2 times t cos of theta. Because the tension in the upper part is t cos theta, the tension in the bottom part is t cos theta. That's why I've multiplied by 2. So this is going to be 2 into t cos theta, which cos theta is 6, divided by 10. So this gives us 12 over 10, which is 1.2. 12 over 10, which is 1.2, or it is 12t divided by 10, or it can be 6t divided by 5. So the answer here is going to be B. A box of weight 40 newtons is pushed with a horizontal force of 20 newtons along a ground for a distance of 2.4 meters. The box is then lifted at a constant velocity through a height of 1.6 meters by vertical force. What is the total work done on the box by the two forces? So work done is going to be of course, work done is force times distance in the direction of the force, force times displacement to be precise. So we shall first of all find the work done in the horizontal and then the work done in the vertical. The work done in the vertical at constant velocity is the work done against gravity, which is equal to the weight. The work done against the weight. So the work done is going to be in the horizontal. The force is 20 newtons. The distance moved in the horizontal is 2.4 plus the work done in the vertical, which is going to be the weight, that is mg, that is the force, times the vertical distance, which is 1.6. So this is 20 times 2.4 plus the weight, which is 40, then times 1.6. We can just check with the calculator. 20 times 2.4 plus 40 times 60 times 1.6. So this is giving us 112 joules. To two significant figures is going to be 110 joules. So the answer is going to be B. Which statement about efficiency is correct? A says the efficiency does not have a unit. Of course, I think the answer is automatically A without even a second thought, because efficiency is equal to the ratio of the useful power output over the power input, either times 100. These have the same units. It's the useful work output over the work input. These ones have the same units, so the units cancel out. The useful energy output over the energy input. These have the same units, so the units always cancel out. So efficiency does not have a unit. So the answer is A. A plane wave of amplitude A is incident on the surface of surface area S placed so that it is perpendicular to the direction of travel of the wave. Perpendicular to the direction of travel of the wave. The energy per unit time. I think energy divided by time is equal to power. The energy per unit time is equal to power, which has been given just E. Okay. The amplitude of the wave is increased to 2A, and the area of the surface is reduced to a half S. How much energy per unit time reaches the smaller surface? Okay. So the energy per unit time reaching the bigger surface is E. The energy per unit time reaching the smaller surface is not known. So I said energy per unit time is equal to the power I have to make this because E has already been taken away from us. I'll use the full word that energy divided by time is the same as power. So this has been given as E. Energy per unit time is power, which has been given as E. And we also know power, because they've talked about amplitude, I must bring in the concept of intensity. And know that power over area equals to the intensity. The power divided by area is equal to the intensity. So in other words, the power which has been given as E divided by the area so E is going to be equal to the intensity, which I will call I, times the area, which area is making power energy per unit time the subject. So energy per unit time is equal to the intensity I times the area, which was initially called S. That is for the first one. But I want you to also remember that intensity is directly proportional to the amplitude squared. So it means for the first one, intensity is going to be a constant times the amplitude S squared. So energy per unit time is going to be equal to K S squared times S. So for the second one, also, for the second one, E2, I'll call it E2, is going to be equal to the second intensity, which I'll call I2, times the second area, which is given as a half S. And what is I2? I2 is going to be equal to a constant times the amplitude, which is twice A, but it is squared. So it means E2 is going to be equal to I2, which is K times 4 S squared times a half S. Alternatively, I can say E2 is equal to a half cancels with that, so it becomes twice K A squared times S. So I have this equation here and this one here. So I'm going to just divide E2 divided by E is equal to twice K A squared times S divided by K A squared times S. So these ones cancel out and I remain with this as 2. So E2 is going to be twice E. So the answer is going to be automatically B. A steel ball is falling at a constant speed in oil. So the acceleration is equal to 0. Which graph shows the variation with the time of the gravitational potential energy? Because the speed is constant, so it means the height decreases uniformly. The height decreases uniformly. Remember, gravitational potential energy is equal to mgh. Mass is a constant, g is a constant. Because the speed is a constant, the h decreases uniformly. So g, gravitational potential energy, should decrease uniformly. That means it should be a straight line. Then the kinetic energy, because the speed is constant, the change in kinetic energy should be equal to 0. So the kinetic energy should be constant, which is a horizontal line. So which graph shows the variation with the time of the gravitational potential energy and the kinetic energy? So we begin with the kinetic energy. It should be a horizontal line, which means C and D are wrong. Then we look at A and B for gravitational potential energy. Because the speed is decreasing, the speed is constant, it means h is decreasing uniformly. So the gravitational potential energy decreases uniformly in equal time intervals. So that means it should be a straight line, making the answer to be B. When a force of 0.8 Newton is pulled to a spring, the length of the spring is 90 millimeters. When a force of 1.3 newtons is applied to the same spring, its length is 115 millimeters. The spring obeys Hooke's law. What is the spring constant of the spring? So this is the force, and this is the length of the spring is 90. And when a force of 1.3 is applied, its length is 115. So by Hooke's law, we know that F is equal to K times X, where X is the extension. X equals to the original length, or the new length, minus the original length. So the question is, what is the constant of the spring? So for the first case, we have that is 0.8 newtons equals to the constant K times the extension, which is going to be 90, minus the original length, which is going to be L naught. Then for the second case, the force is 1.30, which is equal to constant K times 115 minus the original length, which is going to be L naught. So because this is in newtons, and I didn't change these values here, let me just change them to their SI so that I can get L naught easily. So this is 90 divided by 1,000. I think this is 0.0. I'm not good at math. 90 divided by 1,000. 0.09. And this one is 0.115, I think. Okay, so this is going to be, remember, X extension is new length minus the original length. So this is going to be K into 0.09 minus L naught, so that my answer will be in meters for L naught. And this is 0.115 minus L naught. So I'm going to divide the two equations. So I have 1.3 divided by 0.8 equals to K into 0.115 minus L naught divided by K into 0.09 minus L naught. So K cancels first. And this helps us to find L naught. We are cross multiplying. So cross multiplying, I have that 1.3 times 0.09 minus 1.3 L naught equals to 0.8 times 0.115 minus 0.8 L naught. So collect like terms. I would take this the other side, and I bring this one this side, but after simplifying, of course. So collecting like terms, I have 1.3 times 0.09 minus 0.8 times 0.115. So this is giving me 0.025 on one side. Then on the other side, I have negative 0.8 plus 1.3. So the other side, I have 0.5 L naught. So I divide both sides. 0.025 divided by 0.5. So that is 0.05. So the original length L naught is 0.05 meters. So I now want to find K. Now I'm going to substitute for L naught in one of the equations, maybe in the first equation, and I find K. So K is going to be equal to 0.8 divided by 0.09 minus 0.05. So 0.8 divided by 0.09 minus 0.05. So that is 20 newtons per meter. Of course, I take long while calculating this, but I would make this to be very easy. So the answer is going to be D. The answer is D. An experiment is carried out using a metal wire to investigate how to respond to a varying tensile force. The cross-sectional area of the wire is constant. So the cross-sectional area is constant. Which graph has a gradient that is equal to the Young modulus of the metal? Remember, by definition, Young modulus E is equal to the stress divided by the strain. So it means the stress is equal to Young modulus times the strain. And if I sketch a graph of stress against strain, there is no y-intercept, so it goes through the origin. On the y-axis, I put stress. On the x-axis, I put strain. The gradient is the Young modulus, which should be a constant. So if I have a graph of stress against strain, automatically the answer is going to be C. The graph of stress against strain going through the origin, its gradient is Young modulus. This one gives us, I think, force against extension. This gives us K. The gradient gives us K. Extension against force, the gradient gives us 1 over constant, spring constant. Stress against strain gives us 1 over Young modulus. For a wire, Hooke's law is obeyed for tension F and extension X. The Young modulus for the material of the wire is E. So the Young modulus for the material is E. Which expression represents the elastic potential energy in the wire? So we know that elastic potential energy is given by a half K x squared, or it is a half F times X. So the question is, which expression represents the elastic potential energy? So I think the answer is automatically C without even calculation. A plane polarized wave has amplitude A. The wave is incident normal on a polarizing filter. The transmission axis of the filter is at an angle theta to the plane of polarization of the incident wave. What is the amplitude of the wave that emerges from the filter? So if this is the vertical axis, the initial vertical, and then the axis has been transmitted through an angle theta. If we say the initial amplitude was A, and then it has been transmitted through an axis, which is the axis has now moved through an angle theta. So we need to find A in the direction of theta. That is resolving A in the direction of theta. That will be A cos. It will be A cos of theta. So the answer is automatically going to be A. We resolve A in the direction of the new position for the axis. So it is going to be A cos theta. An electromagnetic wave is traveling through a vacuum. What could be the wavelength and period of the electromagnetic wave? So it is an electromagnetic wave, so the speed is equal to 3 times 10 to the power of 8 meters per second. So that is the speed. So what could be the wavelength? Remember, the speed v is equal to lambda times f. So the product should give us, this is the same as v is going to be lambda over t, or I'll say that lambda equals to, lambda divided by t should give us the speed of light. So I will just check these values. For the first one, we have wavelength, which is 1.2 exponent minus 10 divided by t, which is 2.5. Because it is mega, I will say exponent 6. So this is giving us 4.8 times 10 to the power of minus 7. So this one is not the speed of light. Let's check the second one. 1.2 exponent, pico is minus 12, divided by the period, which is 2.5 exponent. This is giga. Giga is power 9 because it is gigaseconds. So giga is power 9. So I'll say times 10 to the power of 9. This is times 10 to the power of 9, which becomes times 10 to the power of 20. 10 to the power of 9 times 10 to the power of 11 becomes 10 to the power of 20. So I'll say exponent 20, which gives 4.8. This is not the speed of light, so this is wrong. Then the third one, remember pico is 10 to the power of minus 12, and nano is 10 to the power of minus 9. So 10 to the power of minus 12 times 10 to the power of 2, it becomes 10 to the power of, we add the power, so it becomes minus 10. 10 to the power of minus 10 and 10 to the power of minus 9, we add the powers, becomes 10 to the power of negative 19. So I now have that 1.2 exponent minus 10 divided by 4 exponent minus 19, which is giving us 3 times 10 to the power of 368. So this one gives us 3 times 10 to the power of 8, which is the speed of light. So the answer is C. Light of frequency 6.7 times 10 to the power of 14 hertz. Remember, I've just been substituting into this formula for all these values, but changing the prefixes. Light of frequency 6.7 exponent 14 in a vacuum is incident normal on a diffraction grating that contains 4.0 times 10 to the power of 5 lines per meter. What is the angle between the adjacent second and third order intensity maxima? What is the angle between this adjacent second and third order intensity maxima? Okay, so we can sketch this. Light of frequency that in a vacuum is incident normal on a diffraction grating that contains 4.0 times 10 to the power of 5 lines per meter. So this is capital N. What is the angle between the adjacent second? So that is when n is equal to 2, and the third when n is equal to 3. So I can sketch this is the screen. This is the central order maxima. Let's say this is the diffraction grating. So let's say this is n equals to 2 and n equals to 3, and we want this angle here. I'll call this angle alpha. So I'll first find this one as theta 1, then I'll find this one as theta 2. Then the difference is going to be alpha. So this is n, remember? And for diffraction grating, we know that small n times wavelength is equal to d sine of theta, which means, and of course we know that d is 1 over n. So which means sine theta is equal to n times lambda divided by d. So for the first one, theta 1. Theta 1 is going to be the sine inverse of n times lambda divided by d. But remember, we say that d is equal to 1 over capital N. So when we say n lambda divided by this is the same as times n. So this is the same as the sine inverse of n lambda times capital N. So for theta 1, I'm substituting to be sine inverse of n is 2. Wavelength, I have again to find the wavelength, but capital N is 4 times 10 to the power of 5. Let me find the wavelength. Lambda is equal to V divided by frequency, which is going to be 3 times 10 to the power of 8, divided by the frequency, which is 6.7, times 10 to the power of 14. So this is the wavelength. So I'll say times 3 times 10 to the power of 8, divided by 6.7 times 10 to the power of 14. So I'll just press my calculator. So I'll say 3 exponent 8 divided by 6.7 exponent 14 times 2 times 4 exponent 5. Then I'll shift sine inverse of the answer. So theta 1 is going to be equal to 20, approximately 21 degrees. Then I'll find theta 2. There's not enough space here, but theta 2 is going to be, I will just substitute sine inverse of, where there is 2, I'm going to put there 3. So it will be 3 times 4 times 10 to the power of 5 times 3 exponent 8 divided by 6.7 times 10 power 11, power 14. So we have 3 times 4 exponent 5 times 3 exponent 8 divided by 6.7 exponent 14. Then we get the sine inverse. Sine inverse of the answer. So theta 2 is equal to 32. Is it exactly 32? 33 degrees to two significant figures. So the angle we want is alpha. Alpha is equal to 33 minus 21, which is equal to, I think this is 12 degrees. So our answer is going to be A. The siren of a moving police car emits a sound wave with a frequency of 40 Hz. A stationary observer hears sound of frequency 49. So this is the normal frequency. 494 is the observed frequency. The speed of sound in air is 340. Notice that this one is higher than the normal frequency, so it must be moving towards. So I will remove A because A is saying away, and I will remove C because C is saying away. Because the observed frequency is higher than the frequency of the source, so it must be moving towards. Then, which one is correct? Is it 37 or 42? So we know that the observed frequency F naught is equal to V divided by V. Because it's moving towards, in the denominator it is going to be minus the speed of the source times the frequency of the source. So the observed frequency is 494. The speed of sound is given at 340. The frequency of the source is 440. The speed is 340 minus the speed of the source, which is going to be Vs. So it means I'll just say Vs, just making Vs the subject. I think Vs is going to be equal to 340 minus 340 times 440 divided by 494. You can make Vs the subject and see what you get. So pressing my calculator, it is 340 times 440 divided by 494. Then I'll say 340 minus the answer, which is giving me 37. So this is going to be 37 meters per second. So the answer is B. The diagram shows the shape of at one instant in time of part of a stretched string as a wave travels along it from left to right. So the wave is traveling from left to right. What are the directions of the velocities of the points 1, 2, 3? Of course, before we reach the peak, the particles on the left-hand side, because the wave is moving from left to right, the particles on the left-hand side must be vibrating vertically downwards to create a trough. Then after that, the particles vibrate vertically upwards until we reach a trough. Sorry, this was to form a crest. So the particles here are vibrating upwards. And then here, the particles must now vibrate downwards afterwards. So one is downwards. So A is wrong, B is wrong, C is wrong. So the answer is D. One is downwards, two is upwards, C is downwards. Three is downwards. Which cannot be a longitudinal wave? Which wave cannot be a longitudinal wave? A diffracted wave, all waves undergo diffraction. A polarized wave, only transverse waves can undergo polarization. So a polarized wave cannot be a longitudinal wave. All waves undergo reflection. All waves can form stationary waves. So a polarized wave cannot be a longitudinal wave. It is only transverse waves which undergo polarization. Microwaves are emitted from two sources at points X and Y. The two waves meet at point Z. The diagram shows the paths of the two waves. The waves emitted from points X and Y are coherent. What is the direct consequence of the two waves being coherent? Direct consequence. Of course, coherence means maintaining a constant phase difference. So if they are coherent, then they must maintain a constant phase difference between them. So A says there is a constant phase difference in the path lengths YZ and XZ. Constant difference in path lengths. Constant difference in path lengths. That is constant path difference, not phase difference. Then constant difference in phase between the two waves at Z. So I think the answer is going to be B, because coherence means maintaining a constant phase difference between the two waves. What is the unit of resistivity? Of course, we know that resistance is equal to rho L over cross-sectional area, and it means rho is equal to R times A over L. Then we write the units. The units for resistance are ohms, for area is meters squared, for length is meters. So it becomes ohm meters. So the answer is D. A kettle is connected to a 250-volt main supply. What are possible values for the power of the kettle and the current in the kettle? So we know that power is equal to I times V. Power is I times V. So we want whatever way you do it, but I think the answer is going to be D. So we can say V is equal to power divided by I. So let's check. We want a V should be 250. We want a pair which gives us 250. For example, the last one is 2500 divided by 10. That gives us 250 volts. They said it is connected to a 20 volts main supply. So the answer is D. Which circuit results in output voltage V out increasing with increasing temperature? We want V out to be increasing as the temperature increases. Okay, that is potential dividers, I think. So which circuit results in the output voltage with increasing temperature? output voltage V out increasing with increasing temperature. Okay. So for this one here, because V out is measured between these 2 points, it means V out will always be the voltage supply. So V out will always be a constant, whether the temperature is increasing or decreasing. Because for a thermistor, this is a thermistor, as temperatures increase, the resistance of the thermistor decreases. That means V of the thermistor, PD across the thermistor always decreases. But the total PD across the two resistors always remains the same as the voltage supply. So A will have no effect whether the temperature is increasing or decreasing. Then let's check B. For B, when the temperatures increase here, when the temperatures increase here, the resistance of the thermistor increases. Because V out is measured across the thermistor, remember V is equal to I times R. Because the resistance has decreased, then it means the PD across R is going to decrease. The PD across the fixed resistor is going to increase. So here V out is going to decrease, yet we want it to increase. So this one is out. Then C, I think C is correct because if temperatures increase here, the resistance of the thermistor decreases. PD across the thermistor decreases, which means PD across V out is going to increase because it must be the same as Vs, because Vs should always be the same as the PD across the thermistor plus the PD across the fixed resistor. PD across the fixed resistor. If here we have PD across the thermistor, so the sum should always be the same. So since V out is measured across the fixed resistor, when the PD across, when VR becomes VT becomes smaller, VR becomes bigger. So it means when temperatures increase, V out is becoming higher because it is measured across the fixed resistor, whose resistance only increases because the current in the circuit has increased. So the answer is C. For resistors, each of resistance R are connected as shown in the figure. Total resistance between X and Y is 120. What is the magnitude of the resistance R? So these three are in series, so they will give us a total of one resistor, which is R plus R plus R, which is 3R. Now 3R is in parallel with R, so total resistance in parallel is going to be product, which is R times 3R over the sum, which is R plus 3R. If you're an amateur, you can say 1 over R in parallel is equal to 1 over R plus 1 over 3R, but this is the same as this here. So they said total resistance is 120, so I'll say 120 is equal to 3R squared divided by 4R. So making R the subject, R is going to be 120 times 4 divided by 3, which is 60 times 4. I think 60 times 4 is 160. We have 120 times 4. 120 times 4 divided by 3. 120 times 4 divided by 3. So that is 160. A cell with internal resistance is connected to a variable resistor R as shown. The resistance of R is gradually decreased. So this means total resistance decreases. Total resistance decreases. That means total current, which is I, increases. I increases. Remember, at the internal resistance, we have what we call the lost volts. The lost volts is equal to I times the internal resistance. So because I has increased, we say the lost volts increases. The lost volts increases. And remember, the EMF E is equal to the terminal PD plus the lost volts. So V is equal to the EMF minus the lost volts. Remember, the lost volts have increased. If this becomes bigger, it means the product becomes smaller. So it means the difference becomes smaller. So it means the V has decreased. The terminal PD decreases. So the current increases. We ignore A and B. Current increases. But then the terminal PD is going to decrease because the lost volts increase. The PD lost in the internal resistance increases. So the terminal PD is going to decrease. So this means the answer is going to be C. The diagram shows a circuit with a cell and three resistors with resistances R1, R2, and R3. The cell has negligible internal resistance. Total resistance of the circuit is R total. What equation for RT is correct? So these two are in series, so their total is R1 plus R2. So because they are in parallel, this resistor here is in parallel with R3. So 1 over total resistance is going to be 1 over R3 plus 1 over R1 plus R2. So let's see an equation related to that, and that is D. Hydrogen and deuterium can be represented by the nuclide symbols H1 and H2, H11 and H21, respectively. What is the difference between hydrogen and deuterium? The difference, of course, they have the same proton number, so they have the same charge. Proton number equals to the charge equals to the electron number. Proton number is the same as the charge is equal to the electron number. So let's see, the deuterium atom has twice the number of electrons as that of the atoms. That is not true. They have the same number of electrons. Deuterium nucleus has a charge, but the hydrogen nucleus has no charge. They both have a charge, the same charge, because they have proton number 1, 1. Deuterium nucleus has less mass than hydrogen nucleus, less mass. These ones have the same mass. The deuterium nucleus has less mass than the hydrogen nucleus. So these ones are going to have the same, approximately the same mass. Then the deuterium nucleus has half the charge per unit mass of the hydrogen nucleus. Let's check the mass per unit charge. Half the charge per unit mass. So for deuterium, the charge is positive E over the mass is 2U. Then deuterium, C was saying deuterium nucleus has less mass. It has actually more mass because for deuterium the mass is 2U, for hydrogen the mass is U, because the nuclear number gives you the mass in unified atomic mass units. Deuterium has the ratio of charge to mass is E over 2U. This is for deuterium. This is charge over mass. Then for H11, the charge is 1E divided by the mass, which is 1U. So you notice that for deuterium, it is half of that of hydrogen. So the answer is D. This one is a half of E over U, and this is E over U. So it means this one is for deuterium, it is half of that of hydrogen. A radioactive sample decays by emitting beta minus particles. The energy released in the decay process is the same for each nucleus that decays, but beta minus particles emitted have a continuous range of kinetic energies. Which statement explains why beta minus particles are emitted with a continuous range of kinetic energies? Of course, beta minus particles are accompanied, these are electrons are accompanied by antineutrinos. Beta minus particles are the normal electrons which are accompanied by antineutrinos, and therefore the energy available is shared between the beta minus particle and the antineutrinos, which gives rise to a continuous range of energies. So Some of the energies released is given to the remaining nucleons in the nucleus. That's not true. Some of the energy released is taken by an emitted antineutrino. So the answer is going to be B. Which particle is not fundamental? The fundamental particles, remember, they are the quarks, the leptons, which leptons include the electron, the neutrino, the antineutrino, and the positron. These are the fundamental particles because they are not broken down any further. So this is fundamental, this is fundamental, this is fundamental, so this is not fundamental. What is the charge of an anti-top quark? So remember, top, charm, up all have charge of positive 2 over 3e. So it means the antiparticles have charge of negative 3e. So it means anti-top has a charge of negative 2 over 3e. So what is the charge of an anti-top quark? Negative 2 over 3e. So the answer here is going to be A. So until next time, bye bye. See you in 1-3.